today we're talking about our next two conic sections, circles and ellipses. And I mentioned before, a circle just is a special ellipse, and we'll see how that is today. Okay, so the definition of a circle is the set of all points in the plane that are a fixed distance r from a fixed point hk. So of course we know the center of the circle, that would be our hk, and that distance that they are from the center, we would call that the radius, right? It's the set of all points that are that far from the center. Okay, standard form of a circle is x minus h squared plus y minus k quantity squared equals r squared, where the center is hk and the radius is r. So what do we know about this circle? Well, I know its center is at x minus the x coordinate and y minus the y coordinate. Remember, inside lies, that looks like positive 2, but it's actually negative 2. And my radius is going to be the square root of 25, which is 5. So just pulling that information out of the equation. Okay, next we're moving on to ellipses. An ellipse is the collection of all points in the plane, the sum of whose distance from two fixed points, called the foci, is a constant. So let's look at the little GIF and see how that works. So if you have two fixed points and the string represents that the sum of those two distances is always the full string length. So let's watch that again. So the string, so if you pull it tight, the set of points that the sum of whose distance from those two fixed points is always that constant string length, those are the ellipse. Now those 2 points are called the foci, and that's going to be important. That's where the sound or light gets concentrated when we're dealing with an ellipse. So those will be important points, and those are called the foci. Okay, standard form of an ellipse, x minus h squared over a squared plus y minus k squared over b squared equals 1, or x minus h squared over b squared plus y minus k squared over a squared equals 1. The only difference between those two forms is that a is always the bigger number. A is always the bigger number, so sometimes a is under x term and sometimes a is under the y term. Okay, the center is still at hk for an ellipse. It's always a greater than b, and we have a plus sign between the terms. So a is always the square root of the bigger denominator, and it shows you which axis is the major axis. So if the bigger number is under x, the major axis will go in the horizontal direction. If the bigger number is under the y, then the major axis will go in the vertical direction. B is always the square root of the smaller denominator. It shows which is the minor axis because it is smaller. All right, so let's take a look at a picture of one and a few additional terms. So we can see this ellipse is longer in the horizontal direction. So the major axis is going in the x direction. The length of the major axis is always 2a. So remember, my denominator is a squared. So I'll square root it and then double it to be the length of the major axis. Really, it's that from the center, we're going to go out a units to get one vertex and a units to get the other vertex. Okay, similarly for the minor axis, we're going to go out b units to get the minor axis and then b units to get the minor axis. Okay, now the foci, we'll look for those in just a minute. The foci are always c units from the center. So it always goes in the same direction for the foci, the same direction as the major axis. It's always c units. But to find c, it's going to look like Pythagorean theorem, only we have a minus sign in between. It's a squared minus b squared equals c squared to calculate our c. All right, so they asked us what is the equation of the ellipse above. So let me erase those stray marks and see if we can figure that out. Whew, didn't know that would happen. Let's reset that page if we can. Or at least get that to pop up. There's more than one way to solve a problem, that's for sure. Okay, so what we need to do, we know our formula is going to be x minus something squared over something plus y minus something squared over something equals 1. And so we're going to count the distance from the center to the vertex, and that's 1, 2, 3, 4, 5 units. Okay, so a equals 5. So that is in the x direction, so it's going to go under the x term and it's going to be squared. So 5 squared is 25. Then I'm going to count the distance to the endpoint of the minor axis from the center. And it doesn't have a special name, it's just called the endpoint of the minor axis. So that's 1, 2, 3 units. So b is 3. So b squared, 3 squared will be 9, and that's in the y direction, so it goes under y. All right, now we need to get our center. We can see it sitting right there. Our center is at 2, -3. So when I drop those coordinates in, it's x minus 2, y minus -3, which looks like a plus 3. And so there we have the equation of that ellipse. Notice that for the equation of the ellipse, you don't need the foci, but if we're working a word problem or something that wants to know the foci, then we'll use the fact that a squared minus b squared equals c squared. And the way I remember this is that it's going to be the opposite sign of what we have between terms. So this has a plus sign between terms, and so it's going to be the opposite there. You'll see what I'm talking about when we learn about hyperbolas next time. Okay, so what do we know about this ellipse? Well, I know the center is at 3, 0, just pulling the x coordinate from the x term and the y coordinate from the y term. So that's going to be at 3, 0. I know that the bigger number, 70, is 7. So the square root of 49 is 7, and that's going to be my a value, and it's in the y direction. That means I'm going to go up 7 units or down 7 units in the y direction to get the vertices. So those are vertices. It's my center. So the square root of 36 is 6, and that'll be my b value. So in the x direction, I'm going to go out 6 units to the right and back 6 units. And those are just the endpoints of the minor axis. Now, it's always hard to draw an ellipse. Just sketch it. Just do your best. It's not, this one is almost the same in both directions, so it looks almost a little more circular, but it is slightly different. Okay, and that's what we know about that ellipse. Let's try another one. Okay, so how is the circle just a special ellipse? Well, if you think about it, the difference between this equation and this equation, an ellipse always needs to be equal to 1. So if we wanted the circle to be equal to 1, we would just divide each of the terms all the way through by r squared. And so that would give me equals 1. So it would be x minus h squared over r squared plus y minus k squared over r squared equals 1. And so the only difference here with an ellipse and a circle is that for a circle, a equals b, which is your radius. A and b are equal, so a squared and b squared are both just r squared. So when the denominators are the same, that's a circle. And if you wanted to get it to look like a circle, you would just multiply both sides through by r squared again, by whatever your denominator is here, and it would cancel your denominators here, and it would get you back to this form there. Okay, so a circle is just a special ellipse. All right, so then if we're in general form here for a circle, we've got ax squared plus by squared plus cx plus dy plus e equals 0. For a circle, a is equal to b. For an ellipse, a is not equal to b, but a and b have the same sign. A and b have the same sign. Okay. So what kind of conic section do we have here? Well, when I look at my coefficient on my squared terms, they're not the same, so it's not a circle. They are both positive, so this is an ellipse. So I know it's an ellipse. Okay. They want us to get the equation in standard form. I've got some little bullets here to help you. We're basically going to do like we did last time, as far as I'm going to group the squared terms, but I need to factor out that leading coefficient. So that's going to be a 4 out on the x squared. Now I have 8x. If I factor a 4 out of that, that's going to be plus 2x. And leave room because we're going to complete that square. But we have a second squared term, so we also have to complete the square there. So I'm going to factor out the leading coefficient on the y squared term. So if I pull that 3 out, that's going to leave me y squared. If I factor 3 out of the negative 6y, that's going to be minus 2y. Leave some room because we're going to finish completing the square. And on this one, I'm going to move that constant to the other side. So that's going to give me a 5 on the other side. Okay, so let's finish completing those squares. So that's going to be 4 times x plus half that middle term. Now, when I square that, that's going to become plus 1. But remember that 4 distributes to it. So to balance that equation, I'm really adding 4 on the left, so I'm going to add 4 on the right. Okay, again, when I complete the square on this next one, it's going to be half that middle term, so that's 1. And when I square it, that'll be plus 1. But when I distribute that 3, I'm really adding plus 3. So I'll have to add plus 3 to keep it balanced. So that's going to equal 5 plus 4 is 9 plus 3 is 12. Okay, we're almost there. Last step to get it in standard form. I'm going to divide each term all the way through by whatever my constant is over here. Because remember, I want that to be 1. So I'm going to divide by 12 all the way through. Now that'll go to 1. 4 goes into 12 3 times. 3 goes into 12 4 times. So that's going to look like x plus 1 quantity squared over 3 plus y minus 1 quantity squared over 4 equals 1. Ta-da! We did it. So we completed the square for the x's, completed the square for the y's, balanced the equations, and then divided through by the constant so that we could get it equal to 1. Okay, so kind of fun getting to use those algebra skills. All right, if we want to graph this one, is it in standard form? Is it ready to go? No, but I can divide each term all the way through by 8 to get it there. When I do that, 4 goes into 8 2 times. That goes to 1. So I have it as x squared over 8 plus y squared over 2 equals 1. That means my center is at 0, 0. My center is at 0, 0. The length of the major axis, the bigger number, is 8, but that's a squared. So a squared is 8. So I'll do the square root of that. So a equals the square root of 8, which is 2 on the square root of 2. Okay. Now, the length of the major axis is always 2a. So that's going to be 2 times 2 on the square root of 2, which is 4 on the square root of 2. Okay. Where are my vertices? Well, they're a units out. They're a units out from the center. So it's nice that my center is at 0, 0 because, and this is the bigger number was under the x. So in the x direction, we're going to go out 2 root 2 in both directions. So that's going to be negative 2 root 2, comma 0. And the other one going the other direction will be positive 2 root 2, comma 0. So those are the vertices. Now, the length of the minor axis, well, the length of the minor axis is always 2b. So let's find b. We know that b squared is 2. So b is just the square root of 2. Now, that's under the y term. So to get to the endpoints of the minor axis, we would go b units in both directions. Oh, but they didn't ask us for that, so we don't have to find those coordinates. They just want the length of the minor axis. So 2 times the square root of 2 is the length of the minor axis. Length of the major axis, vertices. Okay, then the last thing they ask for, they ask for the foci. Okay, so our formula for foci is that c squared equals a squared minus b squared. Okay, again, it looks like Pythagorean theorem, but it has a minus in between. All right, so c is the distance from the center to the focus, and we don't know what that is, so that's what we're solving for. I know that a squared, I can see it right there in my denominator, was 8, minus b squared is in my denominator too, it's 2, so c squared equals 6. Undo the square with square root, so c equals the square root of 6. Now it would be plus or minus the square root of 6. Plus or minus the square root of 6. And so the location of the foci goes in the same direction as the major axis. So for us, this is in the x direction. So from the center, I would go negative square root of 6, comma 0, and I would go positive square root of 6, comma 0. Okay, so this next example, it says find the equation of the ellipse described. Its center is at 0, 0. Center is at 0, 0. And the focus is at negative 1, 0. So there's our focus. and a vertex is at 3, 0. Okay, well, if we have a vertex there, that means this is our A value. And so A is 1, 2, 3 units. Now, if our focus is here, that means we have another focus here. Either way, the distance from the center to the focus is our C value, so C equals 1. Okay, so C equals 1. And so let's start building this. It says find the equation. So let's see if we can get that set up. So we've got x minus something squared over something plus y minus something squared over something equals 1. Now we already know the center, that's at 0, 0, so we can drop that in. We know our A value is 3 and it's going in the x direction, so under x would be 3 squared or 9. And so then we need to find our B value, and we can do that. So we have a formula that says C squared equals A squared minus B squared for an ellipse. We've got a plus sign between the terms here, and so it's a minus sign between in the C squared equals A squared minus B squared. It's the opposite sign there. Okay, so let's plug in those numbers. We know that C is 1, so 1 squared equals 3 squared minus B squared. So that gives me B squared equals, subtract 1 squared from both sides, so 9 minus 1 is 8, so B squared is 8. And we actually only need B squared, we don't need B, so I can go ahead and put it in as B squared under the Y. Now, and they only wanted the equation, so we're actually good to go there. We could leave it like that, or we could write it, if you prefer, as x squared over 9 plus y squared over 8 equals 1. Either one would be okay. Okay. All right, let's take a look. Okay, it says find the equation of the ellipse described. The focus is at 0, negative 4. So let's see where that's at. 0, negative 4 is the focus. Okay, and the vertices are at 0 plus or minus 8. So 0, positive 8 is a vertex, and 0, negative 8 is a vertex. Okay, which means that our center must be at 0, 0. Because the vertex is in the center of the, or rather the center is at the middle of the two vertices. So, okay, so then we know that our A value is 8, and our C value, distance from the center to the focus, is 1, 2, 3, 4. So C equals 4, so kind of like that last one. Let's see if we can find our B value and get our equation. So we've got x minus something squared over something plus y minus something squared over something equals 1. Okay, dropping in our center we said is at 0, 0. Our A value is 8, and it's going in the y direction. So under the y value, we're going to put 8 squared or 64. We need to find our B value. We know that C squared equals A squared minus B squared, the opposite sign that we have from the plus sign between terms. Okay, so that's going to be 16, which is 4 squared, equals A squared, which is 64, minus B squared. So I'm going to add the B squared to both sides, subtract 16. 48, is that what you got? 48 there. Yep, I agree. All right, and so there's our equation. Find the equation. Again, the graph, drawing it out, is just to help us. We're not fully graphing the ellipse unless they ask us to. Okay, last one. Find the center, focus, and vertices of the ellipse. This time we have the equation, and on that last one, you could have written it without the zeros in there, with just the y squared. I thought about it seeing this one. Okay, so this means that my center is at negative 2, 0. Okay, so my center is at negative 2, 0. And okay, that's the first thing they asked, so that's done. And then the focus and the vertices. Okay, so the vertices are going to be the easiest to find next, so let's go ahead and do that. The vertices. So if A squared is 49, then A is 7. Okay, so we've got plus or minus 7. So from the center, and it's in the y direction. So from the center, we're going to go up 7 units to a vertex, and down 7 units to a vertex because it's under the y value. So those are going to be at -2, 7, and -2, -7. Okay, those are two vertices, and they wanted the focus. Okay, so we know a squared and b squared, and we know that c squared equals a squared minus b squared. So let's find that real quickly. That's just going to be 49 minus 36 is c squared. So that means that c squared is 7. Or no, sorry. Oops, wrong direction. 13. Okay, and then so they want the location of the foci. Good. Okay, so C will be plus or minus square root 13. Okay, so it's going to be in the same direction as the major axis, so in the same direction as the vertices. So our foci, that's the plural of focus, are going to be at -2 root 13 and -2 minus root 13. Okay, key things to remember about ellipses: always draw it out. Always get the equation into the form you're most comfortable with, which for me is standard form. A is the larger denominator, and it determines the major axis. The square root of the number under the x term is the horizontal distance from the center. The square root number under the y term is the vertical distance from the center. The foci are always inside the ellipse because remember the ellipse will eat the foci. So if you close the ellipse together, it would eat the foci. The foci are always inside the ellipse on the major axis, and the foci can be found by a squared minus b squared equals c squared.